Our homework last night was page 63, number 2 to 11. We got 2 requests to go over questions here. Question number 6, question number 10. We'll start with number 6. It says, at the beginning of a game, a referee throws a basketball vertically upward with an initial speed of 5 meters per second. Determine the maximum height above the floor reached by the basketball if it starts from a height of 1.5 meters. I think I know right away when I read this where the mistakes were made on this one. This is an acceleration problem. This is a group B problem, right? Before we look at any givens or any equations or anything like that, we always try to look at the bigger picture, right? What kind of a question is it? It's a group B problem. Okay. What do we also know about this? Well, it's an acceleration due to gravity group B problem. So we know that automatically, because it's under the influence, the ball that is under the influence of just gravity, we know that A will be equal to negative 9.81 meters per second squared. When it's going up into the air and when it's coming back down, its acceleration will be negative 9.81 meters per second squared. We know that VI, the initial velocity, is 5.0 meters per second. It's going upward, so we're going to make it a positive value. If you were, I don't know, standing on the bench and throwing the ball downward at 5 meters per second, we'd make the initial velocity negative 5 meters per second. All right, we want to find the maximum height. Let's not worry about this starting height right now, okay? Okay. We want to find the maximum height. What we really want to find here is displacement, right? How far the ball goes. We'll deal with that initial height later on. It's a given, but I don't really want to write it down right now because I think that might just confuse you if we have that written down as a given. All right, so anything else we have besides that initial height? Anything else we have if we read between the lines just a little bit? Yep, Emma? Yeah, if you're only analyzing the trip upwards, then the final velocity would be 0 meters per second. Because when it reaches its peak height, it stops, right? Only momentarily, but momentarily is long enough. So I think what we're going to do there to find delta D is use the equation VF squared is equal to VI squared plus 2AD, which we've used probably literally dozens of times before. Solving for delta D, you got to get rid of what's not attached first. That's the VI. So we take it over by subtracting. VF squared minus VI squared equals 2AD. Then we get rid of what is attached, which is the 2 in the A. VF squared minus VI squared. 2A is multiplied by D, so we take it over by dividing. Equals delta D. VF is 0. VI is 5 squared over 2 times neg 9.81. We do that math, we end up getting negative on the top, negative on the bottom. They cancel to make a positive 1.2742 meters. But alas, that's not the answer that they give us in the appendix of the textbook, 1.27. So what am I missing here? This is probably where that initial height's going to come into play, right, Rosie? Yeah, this is the displacement of the ball. This is how far the ball went above where it was released. But it was released 1.5 meters above the ground. So if we want to find the max height above the floor, then we need to add to that the initial height above the floor. We're going to round it to 3 digits. So it's going to be 2.77. 2.77 meters. How many people got that? 2.77. Good. How many people got 1.27? You're well on your way, right? You just missed that last little bit of adding the initial height to it. Okay, that's one of those things where it's not so much a physics thing, but just a general awareness thing of what we're being asked and what we've already got given to us. All right, and the last question that we have to do today is, it says jumping straight up, number 10, jumping straight up. How long will a red kangaroo remain in the air if it jumps to a height of 3 meters? All right, so this is a Group B problem, because we're accelerating or decelerating. It's a gravity group B problem, because the red kangaroo is under the influence of just gravity here. What do we got? Well, if it's a gravity problem, A is equal to negative 9.81 meters per second squared. How long will it remain in the air? We're looking for delta T. What do we got here? The displacement is 3 meters. That's how high the kangaroo goes. Anything else? Yeah. Oh, yeah, good question. Wouldn't the displacement be 6 meters because it's going up and down? Who says 6 meters? Should be 6. Ooh, you're not getting very much support there. If you want to actually analyze the whole trip of the kangaroo up and down, then the displacement is not 3, but it's also not 6. Displacement would be 0. If you're analyzing the trip up and down, the displacement will be 0 because it ends up where it started, right? It's like that first day of class when we were talking about running around the track outside. You run around the track, your displacement is 0 because you end up where you started. I don't want to analyze the trip up and down because I want a number for displacement. So what I'm going to do is analyze the trip up. And if I analyze the trip up, then displacement would be 3 meters. Now understand that when I do that, I'm going to get the time that it takes this kangaroo just to go up as well. That's what I can multiply by 2. Because if I get the time that it takes the kangaroo to go up to its max height, I can double that time to get the time that it takes to go up and back down to where it started. Make sense? Time is a scalar, so I can double the time, but I can't double that displacement because it's a vector. And when it comes back down, it kind of cancels it. Okay, if I'm analyzing only the trip up, there's one more variable that I have kind of given to me. Vision? VF is what? Good. If I'm analyzing the trip up, VF would be 0 meters per second. Now, somebody might say, oh, wait, I analyzed the trip down, not the trip up. If I analyze the trip down, then displacement will be negative 3, and the final velocity, well, we won't know the final velocity. The initial velocity would be 0 if I'm analyzing the trip down. Okay, I think we got enough here. Let's say D is equal to VFT plus 1/2 AT squared. VF is 0, so 0 times T, whatever that is 0. My equation becomes 1/2 of AT squared. And I'm solving for T here. So let's take the half A over by dividing. D divided by 1/2 A. And then we get rid of the square by square rooting. Yep. Oh, yeah, it is. Yeah. It is minus. Yeah. D VFT minus 1/2 AT squared. So that becomes delta D over negative 1/2 A. Make sense? Thank you. That makes sense, everyone? I just wrote the equation down wrong, right? Get T by itself. We got to square root everything, both sides. So get rid of that square by square rooting. Looks like this. The displacement would be 3 meters over negative 1/2 of negative 9.81 equals delta T. Let's do this on our calculator, okay? Let's say 3 divided by, use some brackets on the bottom here, negative 0.5 times negative 9.81. Let's square root that. 0.782 seconds. But that's not the answer in the book either, because that's the time that it takes this kangaroo to go from the ground to its max height. What do we got to do? Yep. We got to double it, multiply it by 2 in order to get the time that it takes to go up and then back down. So if we do that, let's see what we get here. 1.56 seconds. If you check the appendix in the back of the book for your answer, that's what you would have seen, 1.56 seconds.